In this presentation, I'm going to bring back my guacamole presentation that I've given at several blockchain conferences, but this time hopefully it's going to have a little better audio, and there's going to be a little bit more of a focus on how traceability blockchain can be used and things that we've learned since we started working on it back in 2016. An important thing that I want to cover in this presentation is how blockchain can be used for traceability without disrupting how businesses currently operate. I don't want anyone to get the impression that the idea is to replace systems that have already solved an enormous number of problems for supply chain management and food safety by using the blockchain. I've been a developer for over 30 years, and when I graduated college, there were still companies using punch cards. Now that I've been developing for about 30 years, I can definitely say with high confidence that blockchain is a tool, but it's not a strategic direction. So let's start with this guacamole. There really isn't anything special about this guacamole other than it's the first guacamole on the blockchain. And when people see this guacamole on the store shelves, they never really think about what went into it. So first of all, the 16-ounce package of guacamole started out as a 455-pound batch of guacamole. And this big batch of guacamole didn't just end up as 16-ounce packages. It might have also ended up as 3-pound packages, 8-ounce packages, and it was sold as in bulk to grocery stores who use it in their own packaging and sell it as their own brand of guacamole. It also may have been shipped to other processors in bulk who use it in prepackaged salads or sandwiches. But then on the other side of this 455-pound batch of guacamole, it started out as onions, tomatoes, and avocados that were received from some distributor and were grown on a farm somewhere in the world. Also, these onions and tomatoes didn't just end up in the guacamole. They may have also ended up in a wide range of salsa products that our guacamole processor also makes. So nobody realizes or cares about any of this until something bad happens. So let's say the onions get recalled. Now this is a hard enough problem if the onions are still onions, but it gets really troublesome in our case where the onions aren't onions anymore, and we may not even know what they became once they left our custody. So this is our problem. And this is the problem we want to solve with the blockchain. Now, the first rule of blockchain says that if you have to change the definition of blockchain to fit your use case, then just stop and find a different technology. Before we look into the internal structures of the blockchain to decide if we want to use it for traceability, let's look at how we would really use the blockchain. Now, there are three good use cases for blockchain that will apply to a lot of business. First is immutability. You can store data on the blockchain and you know it's a permanent record safely stored for as long as the blockchain exists. But 20 years from now, do I really care what lot of tomatoes went into this batch of guacamole that I created back in 2018? So probably not. So probably this isn't our focus for using the blockchain. The second is secure transfer data. If my supplier uses one computer system, let's say using Oracle as a database, and I'm using a NoSQL backend on the Google Cloud, can these systems pass data back and forth effectively? Well, blockchain can be a solution for that, but it's not exciting, and there's actually a lot of ways to solve this problem if you can ever get all the parties to agree. So the actual solution to this problem is getting all the parties to agree on a solution to the problem. Okay, and then there's the third use case, which is the really exciting one, and that's building systems that use the feature of blockchain where companies post just enough data to achieve traceability, but not so much data that companies have to worry about the data mining of the proprietary information. So let's explore why blockchain can solve this and why it can be the solution to this problem. Now to do so, we want to go back to the original Bitcoin blockchain launched by Satoshi Nakamoto in 2009. The original blockchain design was laid out in a white paper called Bitcoin.pdf, which eventually became the basis for everything blockchain. One of the core technologies that rarely gets talked about in blockchain by anybody other than data scientists is the algorithm inside a blockchain called UTXO. UTXO stands for Unspent Transaction Output, and it provides the way data is structured and stored within the blockchain. In a cryptocurrency, your account balance isn't just a record in a database like it is at your normal bank where they may be using a relational database. Within the blockchain, your account balance is the sum of all the transactions where cryptocurrency was received, but you haven't spent it yet. So my balance of a cryptocurrency is the sum of my unspent transaction output. Now, a coin within the blockchain is defined as a chain of digital signatures. Each transaction, when it's spent, becomes an input to another transaction. And each transaction can have multiple inputs, which are the source of the funds being transferred, and can have multiple outputs. Now, this seems like a really odd way of storing transactions and balances, but it's necessary because once data is written to the blockchain, it can't be changed or deleted. Now, this is where transparency and traceability come in. The blockchain software can determine if a coin is valid by tracing it all the way back to its source. There are only two ways to have a coin in your wallet. Either you received it as part of a transaction, or you were a miner. And if you were a miner, your account is tied back to the block header of the block that you mined. So, along with other cryptocurrency functions of the blockchain, any coin can be assured to be valid. What this also means is that if I send cryptocurrency to someone else, I can also trace where it goes once it's been sent. Now, this doesn't seem like a great thing for privacy, but privacy is actually the opposite of transparency and traceability. So this comes all the way back to how we want to use the traceability functions of the blockchain. But we're not all that excited about putting proprietary company data on the blockchain or using blockchain as a replacement database. Although data can be protected on the blockchain, it's really hard to convince people that their data is safe. And also, transactions stored in this manner use a lot of storage if your data changes often. So every time you make a change to an asset on the blockchain, you are in effect making a copy of the record in a new transaction. Now, for traceability, this is not a problem because we're only storing data related to traceability. But this becomes a big problem if you try to replace your relational database or your document database with the blockchain. Now, one place to start in this endeavor is to look at the basic things that you need to be able to do with an asset on the blockchain to make sure that we're able to do that. Now, this is the first scenario, and this is the most basic scenario people focus on when they think about the blockchain. This is taking an item and dividing it into smaller units of the same item and shipping it to other people. Now, this models blockchain transfers exactly, so I'm not really worried about that one. Now, the second case is a little bit more complicated. This is our guacamole example. When we are combining multiple assets like tomatoes, onions, and avocados into guacamole. Okay, this is also simple for the blockchain, but obviously there's a couple of other things necessary to make this work for food traceability. In cryptocurrency, a coin is a coin is a coin. But in food traceability, a tomato is not an avocado, and one lot of tomatoes needs to be tracked separate from another lot of the same type of tomatoes. But if you're familiar with tokens in Ethereum, you'll have an idea how this can be done. How this works internally is something that we'll talk about in another presentation. The third scenario is just like the second case, except it's done over a period of time. For example, in cattle ranching, the final product has multiple inputs that are added to it over time. So in the end, the cattle may have had a lot of different things added to it that needed to be tracked, but this didn't all happen at once, like when you're making guacamole and you combine all your ingredients together at the same time. So the third scenario really is just an offset of the second scenario. Now, these three scenarios can actually be combined into two main activities on the blockchain that the blockchain needs to trace for us. These are transfer and transform. With transfer, we're using the blockchain to track a product when it moves from one location to another. With transform, we're using the blockchain to track how one or more ingredients becomes something new, or how something changes when it gets changed or put into a different type of packaging. In both cases, the blockchain is structured with inputs and outputs, which create a linked structure that provides this full traceability. Now, there is one last function that we would need to add to the platform, which is trace. Once the data from the transfer and transform functions are on the blockchain, the trace function would be used to easily trace an item forward and backward through the supply chain. So the trace function is really our goal here. Our goal is to be able to identify a product and then use the trace function to determine where that product was sourced from and where that product went once we've identified that there was an issue. As one last thing, I'll give a few details about the traceability blockchain and food ledger. When I started developing the traceability blockchain back in 2016, the idea was to put everything on the blockchain and use it as a database. But as we started developing the food ledger application, it became really clear really fast that not everything belongs on the data on the blockchain. First of all, the blockchain is slow, it creates a lot of redundant data, and it doesn't make a good database. So we redesigned the traceability blockchain to contain only the data necessary to perform forward and backward traceability, but also allow the blockchain to be used to transfer data from one system to another. To interact with the blockchain, we created three REST API endpoints and made these endpoints so developers really don't have to understand anything about the blockchain to use them. We actually launched our traceability blockchain back on October 1st, 2016, and it currently has over 220,000 blocks created. Now, I know I've left a ton of the technical details out of this presentation, so I'm going to work on some more detailed presentations that talk about some of the issues that you run into using the blockchain for traceability and go into more detail of how these APIs work to be able to store data on the blockchain.